Today's operator signal is this: OpenAI is becoming infrastructure. For the last year, most teams have asked a simple question: which model should we use? That still matters, but it is no longer enough. The better question is, can we inspect the system, run it near our data, adapt it when the workflow changes, and defend it when something breaks? Start with NVIDIA's July 27th Open Secure AI Alliance. NVIDIA says the group includes cloud, cybersecurity, enterprise software, open source, and AI research partners working on open technologies to safeguard software and agents. The key is not just the member list, it is why the alliance exists. NVIDIA points directly to the Hugging Face security incident. During that response, closed AI tools reportedly blocked some forensic analysis because they could not tell attackers from defenders. Hugging Face then ran an open-weight GLM 5.2 model on its own infrastructure to help analyze more than 17,000 actions and contain the intrusion. And that is the case for open defensive systems. When the clock is running, defenders need tools they can inspect, adapt, and operate locally. This connects to the broader open weights policy push. A public letter hosted by Microsoft called Open Weights in American AI Leadership lists a wide coalition that includes NVIDIA, Microsoft, Meta, Google, OpenAI, Hugging Face, Mistral, Cloudflare, GitHub, Mozilla, Palantir, Replit, Versal, Y Combinator, and many others. The argument is not that every model should be open. And the serious version is that open weights create competition, resilience, customization, and sovereign control. For businesses, that means the model decision becomes a sourcing decision: closed API, open model, private deployment, or a hybrid stack. The second signal is that agents are getting real domain tools. On July 26th, NVIDIA expanded its Agent Toolkit with Physics Nemo and CUDA-X libraries so developers can build engineering agents that call physics models, solvers, and quantum chemistry workflows. NVIDIA says Cadence, Siemens, Synopsys, Samsung, and others are applying these components across chip design, verification, packaging, lithography, thermal analysis, and system design. That is a big deal because it shows what useful agents look like outside the demo layer. The agent is not just writing text. It is connected to deterministic tools, simulations, proprietary data, validation loops, and domain-specific metrics. The operator lesson is direct. If you want agents to do serious work, give them tools that can prove or disprove their own outputs. The third signal is the compute feedback loop. NVIDIA said Vera CPU is now being deployed across its own EDA workflows for next-generation CPU and GPU design, with early testing showing up to 1.5 times higher performance on selected verification and simulation workloads. That is not a chatbot feature. It is a supply chain signal. Faster verification means faster chip cycles. Faster chip cycles mean faster AI infrastructure. The companies that can use AI and specialized compute to improve the next generation of compute have a compounding advantage. Then, on July 27th, NVIDIA and Safe Superintelligence announced a long-term partnership. NVIDIA is investing in SSI, and access to the Vera Rubin platform is expected to increase SSI's compute by an order of magnitude. Whatever you think about superintelligence as a goal, the operator signal is clear. Frontier research is being paired with preferential compute access and deep platform collaboration. Compute is no longer just capacity, it is strategic leverage. So what should operators do with this? First, map your model dependency. Which workflows require frontier closed models? Which can run on open weights? Which need local deployment because the data, latency, or incident response requirement is too sensitive for a black box? Second, build a defensible hybrid stack. Use closed frontier models where they clearly outperform, but keep open models and local harnesses available for audit, fallback, red team testing, and continuity. Open does not mean uncontrolled, it means inspectable under policy. Third, treat agent tooling as production infrastructure. Every domain agent should have callable tools, test cases, logs, validation checks, and measurable outcomes. If the agent cannot verify its work, it is still an assistant, not an operator. Fourth, budget compute around bottlenecks. Ask where throughput, latency, simulation time, or model cost is constraining the business. That is where infrastructure investment matters most. The takeaway: the AI stack is splitting into two jobs. Closed frontier systems will keep pushing capability. Open and local systems will keep pushing control, resilience, and trust. The strongest operators will not pick one side as a slogan. They will design the stack so each workload runs where it is safest, cheapest, fastest, and easiest to govern.